Hey guys, welcome to lesson 2 unit 5. Our topic today is simplifying radicals when index is 3. When I say index 3, this is a square root, right? Square root means your index is basically 2. We don't really write about it. When I say index is 3, the 3 is here. This means it can be rewritten as, like if I had x, this is the same thing as writing x to the 1/3 power. That's what the index 3 means. Okay, so I want you to pause the video, try the do now. Try to do it without the calculator. Okay, so it says simplify each of the following. 2 cube. Cube means the exponent of cube means that you're writing this base 3 times. So this is not 2 times 3, but it is 2 times 2 times 2, which is 2 times 2 is 4, 4 times 2 is 8. Similarly, this would be 3 cube is 27, 4 cube is 64, and 5 cube is 125. So this is how you do these. These are actually 8, 27, 64, and 125 are perfect cubes because you multiply the same number 3 times to get that number. So how do you work with simplifying numbers that are not perfect cubes? Very similar to what you did for your square roots. So here, look at 16. Did 16 make your list up there? When I'm saying the list, I'm also going to write 1. 1 cube is 1. 1 to any power is 1. We should all know that. 2 cube is 8. 3 cube is 27. 4 cube is 64. And 5 cube is 125. So anytime you're working with numbers and it says cube roots, you're going to write cube roots. If it said square roots, you would have written square roots, and so on. So 16 did not make my list, but 16 would have been somewhere here, right? So what's half of 16? 8. Did 8 make my list? Yes, 8 is a perfect cube. So I'm going to break it down into a factor of perfect cube and the number. So now what is cube root of 8? Cube root of 8 is 2, and 2 is a non-perfect cube, so this stays under the radical. So this is how you simplify cube roots. So let's quickly now try to fill in the blanks. It's identify the largest perfect, we're working with cube, so perfect cube factor, right? Which will divide evenly into the radicand. Then blank each factor its own radical sign. So give, if there was a sign, perfect and non-perfect cubes, and then what? Simplify, which we did in this part when we said cube root of 8 is 2. Simplify the perfect radical. Variables are perfect cubes if their exponent is divisible by, since it's a cube, it's a cube, so we're going to talk about 3. I'll give you an example. So x to the 9th, cube root of x to the 9th would be what? 9 divided by 3, which is x cube. But what if I get a number like x to the 11th cube root? So 3 does not go into 11. So what do? Is I'm going to break it down into x to the closest number that 3 goes into that's close to 11 is 9 times x squared, right? I'm left with 2. And this is cube root. So what is cube root of 9? It is what? X cube. So this is how we're going to be doing these with the variables. Okay, so this was a perfect cube because it had an exponent that was a multiple of 3. Okay, so we'll do more of those, but I just wanted to bring that up. So example 2, it says 2 times cube root of 54. Again, I'm going to write my cubes. 1, 8, 3 cubes 27, 4 cube is 64, 5 cube is 125. The more you write it is, the better you will get with your cubes, and you don't have to rely on the calculator each time. So now this is just 2 times, right? That's multiplication. If there's no sign, it means it's multiplication. So it's just the coefficient. Now I want to break down 54. Is 54 a perfect cube? No, it is not, because it did not make my list. So I'm going to look for a number that goes into 54. So I literally go to half of 54, which is what? 27. Does 27 make my list? Yes, it did. So it'll be 27 times what? 2. Now, what is cube root of 27? It is what? isn't this, if I want to write this, 2 cube, 3 cube. We did that for the do now also, so you should know 3 cube is 27. So cube root of 27 would be what? Just 3. And then you're left with cube root of 2. 2 times 3 is 6. So 6 cube root of 2. Please be very careful. Don't write your 3 too big. Make sure it's in the index, right? If I wrote it like this, sometimes people will, and then they'll think you can multiply these two. No, that'll be wrong. So be very careful. Cube root of 2, just like I wrote here, okay? Smaller than the other numbers and in the index of your radical. Okay, simplifying radical expressions. To simplify radical expressions, we separate the factors of the expressions into perfect and non-perfect radicals. Simplify each of the following radical expressions. So we can even do that. Again, I am going to write my list. I'm going to write my first 5 perfect cubes. 1 cube, 2 cube, 3 cube, 4 cube is 64, 5 cube is 125. I'm going to even give it 6 cube, 216. In case we... So the first one, again, 128 is not in my list above. It means it's not a perfect cube. So I want to break it down into a factor of a perfect cube and a number. So which numbers out of these go into 128? Anytime you have a number that didn't work, go to literally half of it. What's half of 128? 64. And 64 does work. So I am going to rewrite it as 64 times what? 2. And look at your variable. Your exponents should be multiples of 3. So does 3 go into 3? Yes. So a cube. Now, if it's a perfect cube, you're going to take the cube root of it and take it out. So cube root of 64 is just 4. And this would be cube root of 2. And cube root of a cube is just a. So this is your final answer for a cube root of 2. I'm going to do this one below it. I want you to do the others that I don't do for your practice problems, guys. So please make sure you finish the entire packet and not skip around. So again, I'm going to rewrite them here because you can't really see them. Oops. Zoomed in too much. 1, 8, 27, 64, 125. So we wrote it a few times. So I'm hoping that we can all have them memorized, you know, by the time we're done with this lesson. So again, 24 is not a perfect cube. If you want sure, you can always go to on the calculator. If you do math, then you go down to number 4. So you'll get this cube root thing in your calculator and type in 24. You'll get a decimal. You'll get something like 2.8 or something. So you know it did not work. That's how you know it, right? And moreover, it didn't make your list. That's another check. So you do 4. Break it down into a factor of a perfect cube. So what numbers before 24 go into 24? It's 8 times 3, right? Now look at these variables. I'm going to switch colors. Look at the exponent. It's 2. If it is the exponent is less than your index, you leave it as it is. You can't really do much about it. Look at y to the 4th. It's a number larger than 3, but 3 does not go into 4. So what would you break it down into? Y cubed times y to the 1st. Isn't that altogether y to the 4th? But you're breaking it down into a perfect cube and whatever is left of it. And then z to the 1st, we're just going to leave it like that because it's a number. The exponent here is less than your index, so you really don't have to do anything. It can't be simplified anymore. So now this is my perfect cube, so I'm going to start with its multiplication. Remember guys, this is multiplication. So 4 times cube root of 8 is 2. 3 is a non-perfect cube, so I'm going to leave it under the radical. X squared is non-perfect. I like to go in order. Y cube, cube root of y cube will be just y. And then there's another y that stay inside, and z is non-perfect cube also, so it stays inside. Now just simplify this. So what do I have? 8y cube root of 3x squared yz. So that's basically it. Your quick check could be, if you look at all these exponents, look here, I'm going to highlight them actually. If you look at this exponent, here it is what? I'm going to write 1, oops. It's 1 and 1. If you look at all your exponents, guys, the exponents are lower than your index. So that way you know you did simplify them completely. Okay? Now, the next one I want to do is this question. 1 over 5a cube root of 250. Again, I'm going to write out my cubes. 1, 8, 27, 64, 125, 216. So again, 250 did not make my list, right? And what's half of 250? 125. So I'm going to rewrite it as 1 over 5a cube root. Oops, my pen isn't working. Oh, it is. 125 times what? 2. Again, look at your exponents. 3 does not go into 4, but I can break it down. A cube times a to the first. 3 goes into 9, so I don't need to break it down. It means it's a perfect cube. Once you done all the breaking down into perfect cube and its factors, I'm going to take them out. This is multiplication. It's not addition, guys, so please be very careful. So cube root of 125 is what? 5. 2 is a non-perfect cube. Cube root of a cube is just a. Then a is a non-perfect one, and b to the 9th would be just b cube. So simplify it. Look what happens. This is 5a in the numerator, cancels with 5a in the denominator. So I'm left with what? B cube and cube root of 2a. And that's your final answer. Okay? So the next one I want to do is this last one. So I'm doing 4 questions on this page. I want you to do the other 4 on this page and the remaining packet. So again, I'm going to leave this. This is multiplication. So I'm going to leave x over 16 as it is. And it's cube root of 128. I'm going to rewrite my factors. 1, 8, 27. 27, 64, 125. And I don't really need it, but I'm going to write it. So 128 did not make my list. We did that with 128 before also. So it'll be what? 64 times 2, right? Again, whenever you look at the variables, your exponent should be a multiple of 3. 3 or a multiple of 3, right? So x cube would not need to break it down because 3 goes into itself. Y to the 10th, 3 does not go into y to the into 10, so it'll be what? Y to the 9 times y to the first. And z to the 4th would be what? Z cube times, we have 1z left, or z to the first power. So now again, bring it out. If it's perfect, take the cube root. Cube root of 64 is, oh, not 8, 4, my bad. It is 4. Cube root of 2 is non-perfect. Cube root of x cube is just x. Cube root of y to the 9th is y cube. You're basically doing 9 divided by 3. That's how I'm getting this number. I did 3 divided by 3, which is 1, if you want to write that down. Y to the first is non-perfect, and it'll be z to the first, because 3 divided by 3 is 1, and z to the first is an extra z there. So now all you have to do is simplify it. What happens? 4 goes into 4 1 times, 4 goes into 16 4 times. So I'm left with, that 4 is in the numerator, that extra 4, right? So x, and x times x is what? X squared, y cube, z over 4, and cube root of 2yz. You can also choose to write it as 1 over 4 x squared y cube z times 3 cube root of 2yz. And that is your final answer. So finish up the remaining packet. Good luck, guys.